Welcome to this beginner-friendly tutorial on coroutines in C Sharp. If you're new to C Sharp or Unity development, coroutines are a powerful way to handle asynchronous tasks without blocking your main thread. They allow you to perform operations over several frames, which is crucial for maintaining a responsive application, especially in games. Today, we'll cover three fundamental concepts: IEnumerator, yield return, and wait for seconds, explaining each step by step with practical examples. By the end of this session, you'll have a solid understanding of how these components work together and be able to implement them effectively in your own projects, whether you're building a game in Unity or developing other C# applications. Coroutines are particularly great for managing animations, introducing delays, and handling loading sequences without causing your game or application to freeze. Let's dive in and explore the world of non-blocking operations in C#. First, let's understand IEnumerator. It's an interface in C# found in the System Collections namespace that primarily allows you to create iterable objects, much like how you would use it in a for-each loop to step through a collection. However, in the context of coroutines, especially within Unity, IEnumerator takes on a different, crucial role. It enables methods to yield control back to the engine or caller. This means your method can pause its execution and then resume later. To use it for coroutines, your method must return an IEnumerator type. This signals to the C# compiler that your method can contain yield return statements, which are the core mechanism for pausing. Here's a basic example of how you might declare such a method. Public class myCoroutine IEnumerator. This tells the compiler that your method can pause and resume its operations. The IEnumerator interface defines two key members that are essential for its functionality: moveNext, which advances the enumerator to the next element, or, in coroutines, resumes the coroutine's execution, and current, which holds the current value or state that was yielded. For robust resource management, especially in more complex scenarios, it's a recommended practice to implement the iDisposable interface for proper cleanup. Remember, IEnumerator is the backbone of coroutines. Think of it as a pausable iterator that allows your code to execute over time without blocking the main thread. Now, the magic happens with yield return. This keyword is fundamental to coroutines because it pauses the coroutine's execution and returns a value or instruction to the caller, which is typically the Unity engine. The coroutine then preserves its current state and will resume execution from the point immediately after the yield return statement in the next frame or after a specified condition is met. The most common usage is yield return null, which simply pauses the coroutine for a single frame and resumes on the very next frame, allowing other code to execute. You can also yield return a number for frames, like yield return 5, to wait for 5 frames before continuing. A powerful feature is nesting coroutines. Yield return start coroutine will pause the current coroutine until another method has completed its execution. Let's look at a code example. IEnumerator my method debug log yield return null // pauses 1 frame. Debug log yield return new wait for seconds // pauses for 1 second. Debug log. Imagine moving a character across the screen. Instead of a traditional loop that would block everything until the movement is complete, yield return lets other code run, keeping your application responsive. See how it resumes right after the yield? This allows for smooth, frame rate independent operations. For smoother animations, you can combine yield return with time.deltaTime to ensure movement is consistent regardless of frame rate. A common beginner pitfall is forgetting to start the coroutine with start coroutine, which is essential for its execution. Another is trying to use yield return in a method that doesn't return IEnumerator. Remember, yield return is your tool to avoid infinite loops in your update method and distribute tasks across multiple frames. Try this in your IDE. Create a simple script and observe the logs to see the execution flow. Wait for seconds is a specialized yield instruction within the Unity engine namespace, designed specifically for time-based delays. When you execute, yield return new wait for seconds. The coroutine will pause for exactly 2 seconds before resuming its execution. This is a non-blocking operation, which is a critical distinction. It means the rest of your game or application continues to run normally during this delay. Unlike thread, sleep, which would halt the entire thread and freeze your application. Let's look at an example. Using Unity Engine, IEnumerator wait example debug, log, yield return new wait for seconds, / waits 2 seconds, debug, log. This code will wait precisely 2 seconds, making it perfect for timed events such as enemy spawns, UI pop-ups appearing after a delay, or cooldown timers for abilities. A pro tip: wait for seconds uses scaled time by default, meaning its duration will be affected by time.timescale. If your game speed is slowed down, the wait will also slow down. However, if you need a real-time pause that ignores time.timescale, you should use wait for seconds real-time. It's crucial to remember to use the new keyword when instantiating wait for seconds, as forgetting it is a common error. Always use wait for seconds over fixed loops or thread, sleep for delays in game development to ensure your application remains responsive. For variable waits, you can calculate the duration based on game speed or other dynamic factors. Let's combine these powerful concepts to see how they work together in a practical scenario. We'll create a coroutine that uses yield return for single frame pauses, wait for seconds for time delays, and even nests another coroutine, all orchestrated via IEnumerator. Consider this full example. IEnumerator combined coroutine debug, log, yield return null, / wait 1 frame debug, log, yield return new wait for seconds, / wait 1.5 seconds debug, log, yield return start coroutine, / wait for another coroutine debug, log, IEnumerator another nested task debug, log, yield return new wait for seconds, debug, log. This approach creates smooth, efficient code that handles complex sequences without blocking your main thread. To illustrate the benefit, imagine a side-by-side comparison. On one side, blocking code that freezes the application during delays, and on the other, our coroutine example running smoothly. Here are some helpful tips for working with coroutines. First, always stop coroutines with stop coroutine when they are no longer needed to prevent memory leaks or unintended behavior, especially if the game object they are attached to is destroyed. Second, use coroutines for one-off tasks, sequential operations, or time-based events, not for continuous, frame-dependent logic. That type of logic typically belongs in the update method. Third, for effective debugging, place debug log statements strategically inside and around your yield return statements to observe the exact execution flow and timing of your coroutine. To recap what we've learned today, IEnumerator is the interface that enables methods to be pausable and resumable, forming the foundation of coroutines. The yield return keyword is what actually pauses the coroutine's execution and returns control, allowing your application to remain responsive. Finally, wait for seconds is a specialized yield instruction that provides precise, non-blocking time-based delays. These three elements, when used together, provide a powerful and efficient way to manage asynchronous operations in C# and Unity. We encourage you to practice these concepts in a simple Unity project or any C# environment to solidify your understanding. Experiment with different yield return types and observe their effects. For further learning, the Unity documentation is an excellent resource. Thank you for watching this tutorial. We hope it has been helpful. If you found this video informative, please like and subscribe for more C# tips and development insights.